Now moving on to question 2 in tutorial 2. Let's go through the question. So a gas containing 80% of methane, CH4, and 20% helium is sent through a quartz diffusion tube to recover the helium. 20% by weight of the original gas is recovered, and its composition is 50% of helium. Calculate the composition of the waste gas if 100 kilomoles of gas are processed per minute. So this is the schematic diagram. Not schematic diagram. This is the flow chart of the process, and you have the feed in of your untreated gas, and then you have your waste gas, and you have your recovered gas. So although it's been drawn here, but I would like to redraw the process first. Okay, so we will start by drawing the process. So step 1, we shall draw. So you have your feed in, and you have your product out, and you should have another stream called the waste gas. Let's call this waste, W. This one is your product, P. And you have your feed in. Okay. So your feed in contains CH4F at 0.8. The composition of the helium in the feed is 0.2. Whereas you will also have methane at W and helium at the waste stream as well, W. So these we don't know yet. Product, we also don't know yet, it's not given. But we do know that the composition of helium is helium at the product stream is 50%, which is 0.5, which means that you should have CH4 at the product stream of 0.5. So the question says that calculate the composition of the waste gas if 100 kilomoles of gas are processed per minute. Now we will take the basis of 1 minute. Because the question said 100 kilomoles of feed gas are processed per minute. So whatever that we are calculating here right now is based on a 1 minute process, right? Next, so we were given that F is equals to 100 kilomoles. Let's write this down. What else did the question say? So we have another information from the question. Okay, over here, let's look at our question again. 20% by weight of the original gas is recovered, meaning to say at the product stream here, it is by weight 20% of the original feed in. So we know that P is equal to 0.2 F in weight percent. But we need to find P in kilomoles, right? Because our feed is in kilomoles and this is a gas. Therefore, we'll start by, am I recording? Okay. Calculating the total mass in kg of gas in F. So we will find the total mass in kg of gas in the feed stream, and we shall take 1 kilomole of F as a basis. Now we know that F contains CH4 and helium, right? So we shall find it based on the composition here. CH4, there's 80% of CH4 in F, and then multiply by 1 kilomole of F then we have to convert. Now we already, so this is the amount of CH4, but we have to convert it into kg, so we multiply by the molar mass of CH4, which is 16.03 kg per kilomole. Now I want to make this clear is that please do not misunderstand that kg is kg, so then you will be left with 1 over mole. This is wrong. The kg here actually represents the prefix, just like kilometer, centimeter, and so on. Okay, so this is wrong. Now, so what we have here is 12.8 kg of CH4. Let's calculate for the helium. Helium is composed of 20%, 0.2 times, take 1 kilomole of F as basis, 1 kilomole. Same, we have to multiply by the molar mass to convert it to kg. So the molar mass for helium is 4 kg per kilomole, and you will get 0.8 kg of helium. Let's total this up. Total F in kg units is 12.8, 0.8 kg, and that is 13.6 kg. And this is in 1 kilomole of F. Therefore, in 100 kilomoles of F, simple calculation, it is equal to 0. 0.0 1360 kg of F. So we can say that F is 1360 in kg. This is with this given in the mass, we can then directly find P with this equation. P is equals to 0.2 F. So P is equals to 0.2 F, which is 1360 kg, and we get 272 kg. Let's write this down. 272 kg. Now let us look back at the question again. The question wants us to calculate the composition of the waste gas if 100 kilomoles of gas are processed per minute. So what it wants is actually this. These two values should be solved. Since this is a gas, we will need to approach this question using component balance by taking the number of moles, since it is gas. Although we have found P in kg, but to perform component balance, we will need P to be in mole basis. Okay, so with that, we will need to convert P to kilomoles. How do we do that? Okay. We need to form a conversion factor for P, which is the molar mass of P. So whenever we want to convert moles to kg or kg to moles, we will always use its molar mass. Let's take a basis of 1 kilomole of P, okay, as basis. So we want to find in 1 kilomole of P, how many kg is it based on the component, based on the components here. Based on the components here, we want to find out in 1 kilomoles of P, how heavy it is. And that we will take CH4. So in the product stream, CH4 is 50%, which is 0.5 times our basis, 1 kg moles of P. And then to convert it to kg, we will multiply by its molar mass, which is 16.3 kg per kilomole, and we will get 8.01 kg. For helium, same, it is 50%, multiply by 1 kilomoles of P, multiply by its molar mass, which is 4 kilo per kilomole, and you get 2. Total this two, 10.01 kg of P per kg moles of P. Now if you look at it like this, doesn't this form look like a molar mass, right? So with this molar mass based on the composition of P, we can directly use this value to convert P into kilomole. So P in kilomole is 272 kg from what we found before, multiply, or what we say divide by 1 over 1 kg mole over 10.01 kg. Okay, basically we are dividing and we get 27.2 kilomole. Okay, so we already have Rp. Let's fill it in. P is 27.2 kilomole, or you have F, you have P, so what you're left with is W. So we can do magical balance. So in is equal to out. F is equals to P plus W. Therefore, the waste stream is F minus the product stream, which is 100 kilomoles minus 27.2 kilomoles, and you will get 72.8 kilomoles. And all we are left is the composition in the W stream, in the waste stream. So we can straight away find this out from component balances. So let's do component balance. For CH4. What goes in is you have 0.8 or 80% of CH4 in the feed stream, which is, the feed is 100 kilomoles, equals to 50% at the product stream, 0.5, and your product P is 27.2 kilomoles plus X CH4 at the W stream multiplied by the waste stream is 72.8 kilomoles. Okay, then you can straight away find the composition of CH4 in the waste stream, which is 0.912. Next, for helium, you have 20% of helium in the feed stream. Okay, if you are confused with the number, please refer to your question yourself, okay, because I cannot put everything into the screen. Yeah, now you also have 50% of helium in the product stream, plus the helium composition in the waste stream multiplied by W, and you shall get the helium composition in the waste stream as 0.088. Or if you actually don't have to do this part of the component balance. You can straight away do it like this, is equal to 1 minus 0.912, which is the composition of methane in the waste stream, since this is a whole number. Alright, so this is your final answer.